Good morning, my YouTube viewers. In this video, what we're going to be doing is we're going to be doing a practice problem on a binomial distribution. And the binomial distribution is basically when you have one of two outcomes. So you can have yes, no, true, false, on, off, 1, 0, things like that. And then so basically you run so many tests and then you have a percentage rate of how many successes that you got. So that's basically what a binomial distribution is. And so now what we're going to do is we're going to run a test on dice rolls. That's the practice question that we're going to work on. And it says, what is the probability that you will win 3 times in 10 rolls of dice? So we're going to write a program in Python to solve this question. And in order to write the program in Python, what we're going to have to do is we're going to have to import SciPy, which is Python's scientific library. So from scipy.stats, import binom. So SciPy is the scientific library. Stats is a statistical module within SciPy. And binom is the distribution that we're going to use to actually solve this problem. So we're going to set the parameters of the binomial distribution. So n is the number of trials equals 10. And p is the probability of winning a single roll and rolling a specific number, and that's 1 divided by 6, or 0.1667. The number of wins we're interested in is 3, and that's k. K equals 3. So you're going to have 10 dice rolls, and the probability is 1/6, and you want to win 3 times out of 10. So what we're going to do is we're going to calculate the probability of exactly 3 wins. So probability is binom, that's your binomial distribution, .pmf, that's probability mass function, brackets k equals 3, comma, n equals 10, comma, p equals 1 divided by 6. And then we print the probability of winning k times the n rolls of a dice is approximately the probability. So that is 0.15 times 0. So in order to win 3 times out of 10, you have a probability of 15.5%. So the next question is, what is the probability that you will win at most 5 times in 10 rolls of dice? So again, we're going to try this again. So we're going to, from scipy.stats, import binom. So binom is the distribution that we're going to be using to solve this problem. So n is the number of trials, it's 10. Probability is the probability of winning a single roll is 1/6, or 0.1667. K is 5, that's the number of times that you want to win. And we're going to calculate the cumulative probability of winning at most 5 times. So probability at most 5 times equals binom.cdf, that's cumulative distribution function, brackets, k equals 5, comma, n equals 10, comma, p equals 1/6. And then you print the probability of winning at most 5 times. And n rolls of dice is approximately the probability at most 5. And so that's 0.9976. So the probability of winning at most 5 times is 0.9976. So if you'll see, in this one we're using cumulative distribution function. And in the prior question, we're using PMF, that's a probability mass function. So depending upon the question that you ask will depend upon what function you're actually going to be using in the binomial distribution. So we have another question. What is the probability you will win less than 5 times in 10 rows? So again, from scipy.stats, we're going to import binom. We're going to set up the parameters of the binomial distribution. N is the total number of trials equals 10. P is the probability of rolling the dice that you want. So 1, 6 or 0.1667. K equals 5. And we calculate the cumulative probability of winning less than 5 times. So probability less than 5 equals binom.cdf. So that's cumulative distribution function. Brackets K minus 1. So that's 4, comma N, comma 5. Sorry, P equals 5. Sorry, P equals 1.1 divided by 6. And then we're going to print the probability of winning less than 5 times in N rows of dice is approximately probability less than 5. So that's 0.9845. So the probability of winning less than 5 is 0.845. In the previous question, you used a different function with the binomial, and you had just a slightly higher rating. So now we're talking about the survival function. What is the probability you will win at least 3 times in 10 rolls of dice? And that's your survival function. So from scipy.stats, we're going to import binom. In the parameters of the binomial distribution, N equals 10, that's your total number of trials. P, that's your probability, equals 1, 6. That's the probability of rolling the number on the die that you would like. And K equals 3. And so probability at least 3 equals binom.sf, that's survival function. And brackets K equals 3, comma N equals 10, comma P equals 1, 6. And then we print the probability of winning at least 3 times in N rolls of dice, approximately, and the answer is 0.0697. So that's about 6.9%. So the next one, we're going to try a survival function as well, but we're just going to try a different way to do it. So a different way to write the same thing is prob least 3 equals 1 minus binom CDF, and that's cumulative distribution function. So we're just running it again. So you can see that the survival function is 0.0697 and the 1 minus CDF cumulative distribution function, that's what 0.697. So that's just giving you the same value. You're just writing a little bit different formula and the same value to get the same thing. So what I'm going to do is I'm going to delete this cell because we're just because it's just telling you exactly the same thing and just a different way to do it. But if you're using SciPy, then you can use the survival function. But if you're using Excel to calculate these, then you'd have to use 1 minus binomial CDF and whatever the formula is in Excel. I've done it in Excel before, but that's just a way that you would do it. And so in Python, there's 2 ways that you can answer this question. And I wanted to put both ways of answering this question in the question, so you'll know that there's 2 ways that you can answer the question. So that concludes this video. The next video is going to be on tax returns using a binomial distribution. So I hope that you decide to watch it.